Good afternoon to one and all. So today we will discuss fifth unit. Today we'll start that fifth unit. So we have completed the four modules. So remaining one module is left. See, today we will discuss about analysis of time series. So here today we'll discuss what is meant by time series and how what are the what are the components of time series also there. So we will discuss one by one. So today we will discuss the introduction of time series. So here. Yeah. So as you know that what is the time? See, same the time series is a sequence of observations on a variable made at regular points. For example, whatever we are going to collect information, so that is observations which are on a regular points or regular intervals. So that is called time series. For example, if you take into account, if I collect information from you that what is your weight at the age of 1 year, so what is your weight at the second year? What is your weight the third year? What is your weight in the fourth year? Like this. So if I collect information from you in the sequence observation on a variable, the made at regular point, something but year by year, if I collect information, that is time series. For example, if I want to produce something, for example, if you're running an industry, you're going to produce some commodities. So how much the production in a particular day? Day one, how much production? Nothing but how much you have done production. The second day, how much you have done production, and third day. So if I collect information from the day by day or day to day, so that is called time series. On the base of time only, if you collect some information with regard to some particular variable, that is called time series. Simple. Here, a time series is a sequence of observations on a variable made at regular points or interval of time arranged in chronological order. Chronological order, nothing but small to big or big to small. Nothing. If you take into account from 2000 to 20 or 2020 to 2001. So like this, if you collect information on the base of regular points or regular intervals about some variables, that is called time series. So the numerical data ordered over time. So whatever we're going to collect information, that should be ordered over time from 2010 to 2020 or 2000 to 2020 or 1950 to 1991 or 1952 or 1948 to 2020. See here, the time intervals can be annually, so year wise, maybe it may be quarter wise, it may be daily, it may be hours, it may be seconds. For example, if you take as stock market, stock prices, second by second, the stock price may be happens, nothing but may be fluctuated. So if you collect information from second wise, if you take hour wise also, and if you collect information about gold daily, what is the price of the gold per day? Today, the price may not be the same for the tomorrow. So if you collect information second wise, hour wise, daily, weekly, okay, weekly, monthly data also we can get monthly, quarterly, half yearly also we'll get annually. If you consider that agriculture sciences, we will collect once in 5 years. That is also time series data. If you want to collect information from the census, so you will get census reports once in 10 years, nothing but the census data will collect once in 10 years. For example, if you take into consider census data, 1991, 2001, 2011, and 2021 or 2021. So this is the data, the time series data. Examples. The sequence of the observations is most important. So whatever we are going to collect information, we should be maintain a sequence. See, the economic data, time series data, generally economics and business activities, which provides us to with example of time series such as prices. For example, if you take onion prices daily, if you take production per season, for example, if you take paddy, maize, cotton, or any products, for example, any production of the activities, unemployment, how much the government is giving some employment to their country people or state people, employment. And poverty, how much poverty is there in our state or district or country. Year wise also we will get GDP, quarterly GDP we will get it, and monthly GDP we will get it, and year wise GDP also we will get it, and the expenditure of the government. So these are the called time series data. Then I will show you that how it is the time series, how we can get it. See, your example, if you take the production of a company, for example, okay. See, for example, in your home, for example, if you are belong to a farming community, for example, in 2010, you have some land and you are going to cultivate a cotton, for example. So in 2010, your total production, that is the production. Here, sorry, is it typical mistake? See here, if you take year wise 2010, so how much you have done? How much you produced the cotton? 10 tons. 10 tons. So your production is tons. So in 2011, how much you produced? 12 tons. 12 in the 12, 16 tons. 13, 13 tons. 14, 18 tons. In 2015, you produced 20 tons. So this is the time series data. If you collect information on a regular points or regular intervals, for example, 2010 and 2011, year wise, this is called year wise data. If you want to collect daily also, for example, second wise, second, third second, fourth second, like this, you can take stock prices. And if you take uh, what it means, for example, hourly, weekly also, for example, wholesale price index, wholesale prices in the particular week, or retail prices in particular week. And if you want to collect information monthly, the production also will take monthly production in industries. And if you want to produce, if you want to take data on quarterly, you will take GDP quarterly data. Here also you will get it. So this is called time series data. Time series data. So I'm going to show another one. Please look at this one. So see, yeah, the time series data, stock prices. Stock prices. Say, for example, in 11 a.m. year wise time, 11 a.m. the stock price value. For example, any some commodity stock price is 74 rupees. Okay. And at 12 a.m., what is the stock price? And 1 a.m., 1 p.m., what is the stock price? 2 p.m. at what is the stock prices? See, when you collect information on the hour wise, this is the stock price. This is also time series. Okay. For example, if you take another example year wise in 2001, 2, 3, 4, 5, the sales. For example, if you take if you are running a business, how much sales in your company? So this is the sales. So this is about the examples of time series data. So as I told you, that time series analysis enable us to determine the useful pattern. For example, when you look at this time series data, so we can easily understand what is the pattern, whether it's increasing trend or decreasing trend. We'll get it easily. So for example, if you observe this one 74 to 75, and it can be decreases, and it can be decreases, it can be decreases. So over the particular period, we can come to know that what is the trend. So here, the time series analysis enable us to determine the useful pattern in the data with the help of the statistical tools. So there are some statistical tools which will analyze the time series data. So basically, before entering to the time series data, we need to understand that what is meant by cross section and what is meant by time series. We need to know that what is the difference between the cross section time series. Here, the cross-section analysis or data, it means that cross-section data is a data which is collected at a point of time. At a point of time, that is called cross-section. And time series data is the data which is collected at a over a period of time. Over a period of time, that is called time series. Here, the time series data is convenient to represent graphically either by joining the points by straight line or smooth curve. So here, when we have the time series data, it is very easy to represent graphically either graph or points or line. So here, see, when we have the data, times the data, so when you plot the graph, easily we can show or we can represent about the stock price. Here, sales. For example, if you take this is a time series plot. A time series plot is a two-dimensional plot of time series data. For example, if you take US inflation rate from 1975 to 2001, so if you take year-wise, see the vertical axis measure the variable of interest. That is a horizontal axis correspond to the time period. For example, see the vertical axis, there is the inflation rate, how much inflation rate, 0, 2%, 4%, 6%, 8, 10, 11, 12, 13, 16. Then if you take horizontal axis, that is the x-axis. So in x-axis, we have taken year at the time. So in 1975, how much the inflation rate is there in the US? And in 1976, how much inflation rate is there? So it is a time period, nothing over a period of time from 1975 to 2001 to. So what is the inflation rate the US country has? So easily we can understand there is a decrease, and after that 1976 it has taken place, nothing but the inflation rate has been increases up to 1980. So later on it has been decreases up to the 1983. So after 1983 it has been slightly increases, then it is decreases, then it is increases, and there is a downwards trend. So after 1998 there is a slightly the increases of inflation rate, then it falls down. So here when we have the data, easily we can represent. So what data tell us? Nothing. Is there any positive trend or negative trend? Is there any fluctuations over a period of time? So if you take any data also, you can put a graph, then you will come to know that how that data is trending. Nothing but what is the variable trend, whether there is a positive trend or negative trend, or that is a constant over a period of time. Then see if you take another graphs. So this is one of the another graph. This is a crime rate, crime. See burglary, larceny, motor vehicle theft, and robbery. See if you take so what is the rate of theft or what is the rate of crime which is happening over a period of time 2014 to 2015? So we can easily understand that which type of crime has uh, increases over a period of time, and which type of crime has been decreases from particular time to particular time. So easily we can show, see, most of the police department will show that what is the crime rate in a particular cities and particular state and particular country. So easily we can understand that particular period. So the crime rate has been decreases or the crime rate has been increases in a particular city. And when we observe time series data, there is a fluctuations due to a number of forces. For example, if you observe this kind of graphs, so there is some fluctuations. See, so from year to year, there's increases and there's a decreases and ups and down. That ups and down is called fluctuations. So if you observe here also, there's some fluctuations of the inflation rate in US. If you observe time series data here also, your stock prices, there is some fluctuations. If you observe here also, there is some fluctuations in the sales. Here, if you observe, there is a fluctuation. Say 10 to 12 increases and section also increases. Then after that, there is a decreases, and later on it is increases. So there is a ups and down. It is called fluctuations. Why there is a fluctuation in the time series data? There are certain factors which can influence, or there are number of forces which can influence the time series fluctuations. Generally, we will call them components of time series. Generally, when we have that fluctuations in our time series data, so why there is a fluctuations? There are some number of factors which can influence that fluctuation. It may be decrease, it may be increase. There are other factors which can increase, which will cause to increase the sales, production, or fluctuations, or sorry, that is inflation rate or the other the crime rates. Okay, so there are number of factors which can influence this kind of variables. So that are called in statistics components of time series. So time series may be affected by the factors. So there is a recurring and non-recurring factors. So as I told you that time series that is affected by the some factors. So some are knownly factors, some are unknownly factors also which can influence the time series data. So such as recurring and non-recurring factors. And second one is the periodic and random factors. Periodic nothing but so frequently the factors can influence the time series data. Then randomly some of the factors which are randomly can affect the time series data. The main thing when we have that fluctuations in our time series data, the fluctuations are called here components or variations. So that is time series components or variations. So this is a very important topic in our syllabus. So sometime they will ask the question that what is mean by time series and explain the what are the components of time series analysis. This is the main question. What is mean by time series and explain the components of time series analysis. So what are the components are nothing but components are nothing but fluctuation, nothing but variations. So why there's a variations in time series data? Then we need to understand. So generally the time series components, there are four types of components or four types of variations in time series data. First one is a secular trend or secular or trend component. Secular or trend component. Second one is the seasonality component or seasonal variations. Simple seasonal variations. Third one, cyclical variations or cyclical component. Then the fourth one is the random or irregular variations or irregular components. So simple, you can keep in mind that there are four components of time series analysis or four types of time series variations. So the first one is a secular trend. Second one is a seasonal variation. Third one is a classical cyclical variation. Fourth one is a random or irregular variations. So these are happen in the time series analysis or time series data. Then one by one we will discuss. The first one is a secular trend. Secular trend. So generally secular trend or trend component indicated with the T. You can remember the first thing is secular trend component is indicated by T, capital T. So generally the secular trend or the trend component is general smooth long-term movement. Smooth long-term movement. So when you take a large number of observations, for example, 30 or 40, 50 observations, so which is a long-term trend. Nothing but when you take the data from 1950 to 2020, so 70 years data, if you take year-wise data, so 70 years is nothing but is a long-term data, long-term movements. So we can easily observe from 1948 to 2020 of the our Indian GDP. It is gradual movement over the whole period, showing a persistent growth. For example, if you compare from 1950 to 2020, so easily we can observe there is a positive growth or negative growth. Easily we can identify. And we can also look at that decline or any other long-term tendency. Is there any long-term tendency over a period of time? Then we will also observe when you the data. So, for example, long-term increases, long run increases or decreases over time. There is a overall upward or downward movements. For example, during the 1940 or 1950 to 2020, if whatever you have taken some data, if it is increasing trend, so automatically the overall upward movements. Nothing but overall the time series, the variable value, it shows that upward bias or upward and data taken over a long period of time. So generally, when we have the long-term data only, we should have to plot that is what is it called a secular trend or graphical. So whatever we are taking data, that is we should have to take over a long period of time series data. So generally 30 or 40, 50 years only, we will easily come to know that is there any positive trend or negative trend also we can observe in the trend component or secular trend component. So for example, if you take sales, this is a time. If you take an x-axis, this is a time. This is a sales. So if you take it from the 1991 to 2020. So from that particular year from 1991 to 1993-94, the sales may be increases. Later on, it can be decreases. After that, 1955, 1995, 97, if you take, so the sales may be increases from 1997 to 2000, 2020. So later on, it can be decreases from this point to this point. Later, it can be increases. So when you compare from year to year, if you find out the an average graph, there is some positive growth rate in the trend, or we can observe easily there is a positive growth rate in the secular trend or secular variation. So this is a see we can take some examples. See, when you observe this trend component, easily see the trend can be upward or downward. So as I told you that it can be upward, it may be downward. See, if you take this is the downward, is the upward. But within the trend also, we can easily observe that is a linear and non-linear. Linear nothing but whose the power value is equal to 1. So if it is straight line, that is called linear. If it is not a straight line, it should be called non-linear. So if you take this one, this is a downward trend. So which is the dots are very close to this point. So this is called straight line. See, if you observe this from non-linear trend, so if the dots are very not close to the particular straight line, that is called non-linear. So at the same time, the particular x variable cannot be determined the y also, and the proportion is not same. So in that case, we will get a non-linear curves. Non-linear curves. So if you take the series and here upward non-linear trend, that is so here times time on x-axis we have taken time, y-axis we can take sales. So generally, if you simple compare, if the dots are very close to the particular line, which is called on linear trend, which is the power value is equal to 1, the power value is equal to not equal to 1. For example, the equation, the power value is not equal to 1, that is called non-linear trend. Non-linear trend. Is it visible, this picture? Hello? Hello? Are you
Yes,
there?
sir. Yes, sir. Yes, sir. Yes, sir.
See, the trend, as we know that there is some short-term fluctuations also there, but here in the long term, we can ignore the short-term fluctuations. So this type of trend are divided into two types of trend, as a linear and non-linear. So as I told in the beginning, what is linear and what is non-linear? If the power value is equal to 1 in the particular equation, so the particular equation is called linear trend or linear equation. For example, if you observe this kind of two graphs, in the first one, this and this, so you can observe this is a downward trend, this is a upward trend. Am I right? So if you observe this one, see this is a non-linear trend, nothing but which is not a straight line. Here it is not also straight line. So this is a simple example for the trend which ignores that short-term fluctuations. Simple, you can remember a note that is the trend. So which ignores the long-term or short-term fluctuations. Sorry, the trend which ignores the short-term fluctuations. Short-term fluctuations. The next one, if you observe, seasonal variations or seasonal components. See, in the seasonal variation that occurs regularly at specific intervals of time. So if you take into account seasonal variations, see, generally when we are taking some commodities, when we are interested to purchase some commodities, the season wise. Example, whatever there is a good demand for seasonal fruits, there is seasonal variations. For example, each and every time the crop cannot give the fruits. So during the season only, there is a good demand and there is a good sale and more sales. For example, if you take seasonal variation that occurs regularly at a specific intervals of time. So the seasonal variation which will occurs at a particular season only. For example, if you take seasonal movements or cyclical of relatively short duration. So as you know that seasonal movements which are very short duration and short-term regular waves like patterns. For example, as we know that the seasonal variations which are very short-term, not long-term, and seasonal variations covered within a 1 year. So generally in the previous years, whatever the seasonal variations occurs in the nature, so that can be observed within the 1 year. So here next one is often monthly and quarterly. Most of the seasonal variations which are oftenly occurred monthly and quarterly. And mostly the related to seasonal factors and customs. For example, the why the seasonal variations can occur, so which are mostly to seasonal factors and customs. So what is the seasonal factors and what is the customs? So see, for example, the sales of cool drinks and rainfall, agriculture wages at the time of sowing and harvesting, etc. For example, if you take the sales of cool drinks, so if you take the sales of cool drinks from February to June, the sales will be high because due to some weather conditions or climate conditions. So for example, if you take the agriculture wages or rainfall. So if you take rainfall, but in the particular season, the rainfall is very less. Then the next one is the agriculture wages at the time of sowing harvesting. For example, within the agriculture farmers, if the farmers can do some work for the agriculture, so they will ask money, but they can ask the wages. So the agricultural wages at the time of sowing and harvesting season. For example, see, when you observe in the villages, the labor cost is very high at the time of sowing and harvesting, because each and every people, most of the people, they are working in their own field. But if you want to work nothing but if you recruit as an employee, or if you recruit a person who is on the base of daily basis, for example, gardener garden, in order to maintain the garden, you can employ 1 or 2 persons. So if you take agricultural labors, that is agricultural wages, for example, whatever you are going to give the wages. So the sowing, nothing but when we are putting seeds in the land, so that is called sowing season, nothing but when we are putting plants in the crops in the field. So that is called that wages very different from that sowing season and harvesting season. For example, there is a lot of demand for the laborers at the time of sowing and at the time of harvesting. So that is the case. Also, we will look at the study. Then, if you observe seasonal variations, see components. So, for example, if you take the time quarterly wise, so if the sales of the winter it will be happen after winter, it may be sales will be down in the spring. So after spring, if the summer will takes place, so automatically the sales will be increased. Later it can be fall down. There is a falls. Then it can be increased. It can be decreased. It may be increased or decreased. So there's a ups and down. There is called seasonal variation. If the season is there, so there is a high sales for the, or more sales for the particular commodities. That is season 1 and season 2. So as I told you that, so what is the main reasons for seasonal variation occurs? First one is the natural forces, for example, weather conditions. There is the climate conditions. Sales of coolers. For example, if the weather is too hot, most of the coolers will be sold. In the particular period, the sales will be at peak level. After that, the weather is cool, nobody have to purchase the coolers, then the sales will be down. If you take ice creams, also in the summer season, the ice cream sales will be high. For example, if you take umbrella in the rainy season, most of the umbrellas will sell. After that, only less number of umbrellas will sell. Then what is the customs and traditions? So due to customs and traditions, the seasonal variation may occurs. So for example, the customs and traditions of the family members, or for example, their habits, their fashions, their festivals of the people in the society. For example, if you take in the particular season, for example, in the month of August, September, so what will happen, or September, October, so the Dasara will come, for example. And during Dasara, so due to some customs or tradition things, so all must have to spend some money for the clothes. So here the festivals of the people in the society will be happen. So these are the main reasons for seasonal variations in the time series analysis. Then third one, there is a cyclical component or cyclical variation. So as you know that what is the cyclical components, when you are studying the business, when you study the microeconomics or macroeconomics, we learn, I think you learned about the business cycles. See, the cyclical variation refers to the recurring variation in the time series. Recurring, nothing but, so once it can be peak and automatically down and automatically can take place up, nothing but the peak level. So for example, when you observe the cycle wheel, so whatever the wheel is upstate on the top, so automatically it can takes down, then later on it can be takes up. So here it can be like this, rotating the same way. The cyclic variation refers to the recurrent variation in the time series, where the duration is more than 1 year. So generally, the cyclic variations which will occur, the time of the duration is more than 1 year, more than 1 year. But whereas seasonal within the 1 year. The long run movements which represent constantly recurring rises and falls in the variable under the consideration. So when you observe the long run data, simply we can represent our constant recurring rises and fall in the variable under the consideration, whatever the variable we are considering. So on the base of that variable, easily we can show that where there is a up and where there is a low. Nothing but ups and down. See, if you observe the business cycle, for example, see, this is a first boom. Nothing but the economy is taking place. Nothing but the economy is growing. There is a boom. So at a particular time, at the point, the GDP will be high. There is a peak level. So after peak level, it can be decreases. That is when there is a decrease in the trend. That is called recession. Okay. So then it can comes under the depreciation. Then after at the lower depreciation, there is a where there is a lower rate, that is called trough. See here the trough generally the trough value is very less than previous year, and it can be less than future year. That is the YT minus 1 less than or equal to YT, and greater than or equal to less than or equal to YT plus 1. YT plus 1. Then I will show you that. So this is the best example for cyclic variation. See, it's a boom, then peak, That can sit down, it comes down, there is a depreciation or recession, then it can be recovery. So this is called cyclical variation or cyclical components. So this is another example. See, if you take same thing, that is a bin cycle. See at peak level, for example, as I told you, the peak level, what will happen? The YT is equal here. See YT value is here, the GDP. The GDP is less than the its previous year, and it can be greater than average. Nothing but so next year it may be GDP is this much, for example. So this year this much. So whatever we are given the peak level, the peak is YT minus 1 is less than YT greater than YT minus 1. YT minus YT plus 1. Sorry, YT plus 1 at peak. So if you take trough place, so YT minus 1 less than get. Is it visible PPT? Hello? 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 Hello?
Yeah, sir. Yeah, sir.
Yes, sir. Yes, sir. Yes, sir.
Yeah. See. Sorry for disturbance because some due to lack of proper internet connection only. See, if you observe this one, cyclical component, see at peak level, this one peak level here. So here YT, that is a YT minus 1, whatever the value will be there. So it is highest value compared with its previous and its future value, YT plus 1. Then if you take trot value here depreciation. See here, whatever the previous value is there, so it should be higher than the present value, there is a drop value, and which is lower than the its future value. That is a YT minus 1 is greater than YT less than YT plus 1. This is very important for the running examination. They will ask set peak level is the peak level, the present value is higher than future value or last previous year value. They will ask such kind of question. Then see, for example, if you take this one cyclical, so long-term wave like patterns. For example, long-term waves. For example, if you observe uh, waves in a lake, see, so there is some ups and down, ups and down. So like this, there is some waves, like wave pattern. So the regular occur, but may vary in the length. So often measured peak to peak or top to trough. So if you observe this top to peak and top to trough, say year to year and year to year. So for example, if you observe from year peak to year peak level, there is a one cycle. Then year to year trough to trough, so there is a one cycle. Then fourth one, random or irregular components. Random or irregular components. Screen is visible for you, Durga Prasad? Hello?
Yes, sir.
Screen is
Yeah, sir.
visible?
No, sir. It's
No,
buffering.
sir. No, sir. It's buffering.
Now? I think it is